Hello there students, I am Teacher Modeja and today we will be discussing about the distance formula, specifically on how to apply the distance formula to prove some geometric properties. At the end of this lesson, you will determine the distance of the given segment and the length of geometric figures using the distance formula, apply the key concepts of the distance formula to prove geometric properties, and solve problems involving distance formula. Now, how do the distance formula and the coordinate proof facilitate in finding the solutions to real-life problems and making wise decisions in life? Let us define the distance formula and the coordinate proof. Distance formula is a formula in finding the distance between 2 points and length of a segment. A coordinate proof is a proof that uses figures on the coordinate plane to prove geometric properties. Let us have first a review on how to locate points on the coordinate plane. So, let us locate the points on the coordinate plane. What does this mean? This means that the value of x is 4 and the value of y is 3. So, the point of intersection is now what we call the point 4, 3 or point I. That's how we plot points on the coordinate plane. I know you can still remember that. How can we find the distance between 2 points? This time, we are going to use the distance formula. But what is a distance formula? Distance formula is denoted by d is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. Now, remember that the distance that we are pertaining to here are always non-negative. It's never a negative, but it can be positive or 0. It is positive when the points are different and 0 if the points are the same. Let us have an example. Let's find the distance between point A with the coordinates negative 4, 2 and point B with the coordinates 3, 4. In finding the distance between these 2 points, you have the option whether you are going to plot it first on the coordinate plane or go directly using or solve directly using the distance formula. So in my case, I am going to plot it first on the coordinate plane. We have point A with the coordinates negative 4, 2 and point B with the coordinates 3, 4. You must identify the first point and the second point. In this case, my first point will be point A. So it will be x sub 1, y sub 1. And point B, x sub 2, y sub 2. Using the distance formula, we can have the values for x sub 2, x sub 1, y sub 2, and y sub 1. The substitute, here we have x sub 2 is 3 minus x sub 1 is negative 4. So, 3 minus negative 4. And then, y sub 2 is 4 minus 2, which is the value of y sub 1, then operate and simplify. 3 minus negative 4, meaning it's addition because negative times negative is positive. So 3 plus 4 is 7 and 4 minus 2 is 2. 7 squared meaning 7 times 7. 7 times 7 is 49. Then 2 squared, 2 times 2 is 4. 49 plus 4 is 53. And 53 is a prime number. So we'll just accept square root of 53 as the final answer. Therefore, the distance from point A to B is equal to the square root of 53. That's how we use the distance formula in finding the distance between 2 points. Now, how are we going to use distance formula in proving some geometric properties? Let us have this example. Let us use the problems in your previous activities. So first, locate the points M, A, and R on the coordinate plane. Then connect these points. Then prove that the figure formed is an isosceles triangle. But this time, using distance formula. So locating the points, we have point M, point A, and point R. Then connecting them, obviously, we can form a right triangle. So using the distance formula, we have to identify the first point. So in my case, we have the first point as M and second point is A to identify the x sub 1, y sub 1, x sub 2, y sub 2. So, by substitution, we have x sub 2 is 2, x sub 1 is 2, so 2 minus 2 is equal to 0. Then, y sub 2 is 5, minus y sub 1 is 1, so 5 minus 1 is 4. Then, 4 squared is equal to 16, and 0 squared is 0. So, 0 plus 16 is 16, of course. And we have the square root of 16 is 4. Why is it that we have only 4? Remember that we have distance between 2 points. We are going to accept only the principal root because distance between 2 points is always non-negative. Next, for segment MR. So we have points M and R. So x sub 1, y sub 1, x sub 2, y sub 2. Segment MR, we have x sub 2 is 6, x sub 1 is 2, so 6 minus 2 is 4. Then y sub 2 is 1 minus y sub 1 is 1 as well, so 1 minus 1 is 0. Then 4 squared is equal to 16, 0 squared is 0, so 16 plus 0 is 16. So we have the square root of 16, and MR is equal to 4. Then therefore, since segment MA is congruent to segment MR, triangle MAR is an isosceles triangle. That's how we use the distance formula in proving geometric properties. Next example. Let us prove that the diagonals of a rectangle LOVE are congruent. Given the points L with the coordinates negative 4, negative 1, O with the coordinates negative 4, 2, V with the coordinates 2, 2, and E with the coordinates 2, negative 1, using the distance formula. So again, plot the points. On the coordinate plane, we have L, O, V, and E. We can form a rectangle. So, we are going to prove that the diagonals of this rectangle are congruent. So, we have the first diagonal, LV, second diagonal, OE. Now, to prove that the diagonals are congruent, let us use the distance formula. So let's start first from point L to point V. First diagonal, we have, so x sub 2 is 2 minus x sub 1 is negative 4, so 2 minus negative 4, that means addition, so that's 2 plus 4 is 6. Then we have y sub 2 is 2 minus negative 1, that means addition, so 2 plus 1 is 3. So we have 6 squared plus 3 squared. 6 squared is 36 because 6 times 6 is 36. Then 3 squared is equal to 9 because 3 times 3 is 9. 36 plus 9 is 45. So we have the square root of 45. And square root of 45 can still be simplified as the square root of 9 times 5. And the square root of 9 is 3. So we have LV, or the first diagonal, is equal to 3 square root of 5. Next, for diagonal OE. So we have x sub 2 is 2 minus x sub 1 is negative 4. So 2 minus negative 4 is positive 6. That means addition. Then y sub 2 is negative 1 minus 2 is negative 3. So like signs, add. So 6 squared is 36 and negative 3 squared is positive 9 because negative 3 times negative 3 is positive 9. So we have the square root of 36 plus 9. And 36 plus 9 is 45. So we have the square root of 45. And square root of 45 can still be simplified as the square root of 9 times 5. And square root of 9 is 3. So we have the answer as 3 square root of 5. So the diagonal OA is equal to 3 square root of 5. Since diagonal LV is congruent to the diagonal OA, then therefore the diagonals of rectangle LOVE are congruent. Okay, so that is how we use the distance formula in proving some geometric properties. Alright, so now you know how to use the distance formula in proving some geometric properties. Now let us try to use the distance formula to solve some real-life problems. Okay, for example, a tracking device attached to a COVID-19 patient prior to his escape from the hospital indicates that he is located at a point whose coordinates are 810. In the tracking device, each unit on the grid is equivalent to 5 kilometers. How far is the tracker from the COVID-19 patient if he is located at a point whose coordinates are 2, 2? Now, to solve this, we are going to use the distance formula. So, I am going to choose the COVID-19 patient as my first point and the tracker as the second point. So, we have x sub 2 is 2, x sub 1 is 8, then y sub 2 is 2, then y sub 1 is 10. So we have 2 minus 8, that's negative 6, and 2 minus 10, that's negative 8. The square of negative 6 is positive 36, and the square of negative 8 is positive 64. 36 plus 64 is 100. So we have the square root of 100, and the distance is equal to 10. But remember that every grid, for each unit on the grid, is equivalent to 5 kilometers. Just multiply 10 units by 5 kilometers, we have 50 kilometers. Therefore, the distance of the tracker from the COVID-19 patient is 50 kilometers. So that's how we solve problems involving distance formula. Alright, we are almost done with our lesson. In this lesson, you have learned how to determine the distance of the given segment and the length of geometric figures using the distance formula. And you have learned also how to apply the key concepts of the distance formula to prove geometric properties. and you have learned how to solve problems involving distance formula. Now, according to Chu,
knowing is not enough. We must apply.
Yes, knowing is not enough. You must apply. So you must apply what you have learned in this lesson. Let us practice. I will be showing you 3 problems or 3 questions and you are going to answer them. So, kindly get your papers. Let us start the test. First question. Use the distance formula to find the distance between point P with the coordinates 4, 3 and point Q with the coordinates 9, 15. Start. Alright, what is your answer? If your answer is 13 units, then you are correct. Congratulations! So the distance between point P with the coordinates 4, 3 and point Q with the coordinates 9, 15 is 13 units. Right, next. Show that the diagonals of rectangle CUTE are congruent. For point C with the coordinates 5, negative 1, U with the coordinates 9, negative 1, T with the coordinates 9, 0, and E with the coordinates 5, 0. Start. Okay, what is your answer? If your answer is the square root of 17 as the length of the diagonals, then you are correct. So CT as one of the diagonals is equal to the square root of 17 and UE as one of the 2 diagonals is equal to the square root of 17 as well. So therefore, the diagonals of the rectangle CUTE are congruent. Okay? Congratulations again if you are correct. Okay, number 3. A map showing the locations of different municipalities and cities is drawn on the coordinate plane. Each unit on the coordinate plane is equivalent to 4 kilometers. Suppose the coordinates of the town of Pilar is 2, 1 and Sorsogon City is 10, 11. What is the shortest distance between these 2 places? Start. Okay, kindly stop. What is your answer? If your answer is approximately 51.22 kilometers, then you are correct. The shortest distance between these 2 places is approximately 51.22 kilometers using the distance formula. Alright, so if you got perfect, then you are very good. Okay, congratulations! We are done with our lesson for today. I hope you have learned a lot. So let's just sum up what you have learned today about the distance formula. What is the distance formula again? Yes, precisely, you are correct. Distance formula is a formula in finding the distance between 2 points and length of a segment. And what is the formula in finding the distance between 2 points? Correct again. D is equal to the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. So that's the distance formula. How about coordinate proof? What is a coordinate proof? Okay, correct. Coordinate proof is a proof that uses figures on a coordinate plane to prove geometric properties. Now, can we use distance formula in solving real-life problems? Yes, of course. Distance formula can be used in solving real-life problems. So, that ends our lesson. If you need more examples about our lesson, you can refer to Mathematics Grade 10 Learners Module, pages 229 to 247. Or Mathematics Grade 10 Self-Learning Module, Quarter 2, Module 9. So that's it. Thank you and see you in our next video lesson.